In this video, we are going to look at absolute value equations and inequalities from section 1.6. And the absolute value measures the distance that a number is from zero. So if you think of the real number line, which is a horizontal line that looks like this, 0 would be kind of in the middle. And so if you are asked to find the absolute value of 2, what you're really being asked is how far away is 2 from the number 0? So you have 2 over here. How far away is that from 0? It's 2 away, right? And so the answer here is 2. The absolute value of negative 2 is asking how far away is negative 2 from 0? And turns out it's the same distance. It's also 2 away from 0, it's just 2 to the left. And so the absolute value of negative 2 is also equal to 2 because negative 2 is 2 away from 0. And so this gives the absolute value the reputation it has as always making numbers positive. So if it's already a positive number, it stays positive. If it's a negative number, it gets switched to a positive number because the absolute value is measuring a distance. So that's why it does that. But most students just remember absolute value makes numbers positive. All right, so imagine if we have an equation like this. The absolute value of x equals 5. What you're being asked for here are numbers whose distance from 0, right? So x is looking for a number. The absolute value is looking for distance from 0 equal to 5. Right? So again, looking at the real number line, here's 0. What numbers are 5 away from 0? Well, if we go 5 to the right, what number will we find? We'll find the number 5. So that's one solution. That's one number whose distance from 0 is equal to 5. If we go 5 to the left, going 5 in this direction, we'll find negative 5. And so there are two numbers that satisfy this equation. So there's two solutions. We have 5 and we have negative 5. These are two numbers that would make this equation true. If we plug either of these numbers in for x, the absolute value is going to make them come out positive and equal to 5. Right? And so these are both solutions. So this equation has two solutions. So what I want you to notice here is the pattern that is being created, because unfortunately our equations are not going to stay quite this simple. And so trying to apply this distance analogy as the equations become more complex gets more and more difficult to do. So what we're going to do instead is just notice the pattern that gets created by this absolute value equation and just apply that to the equations that we see later that are more complicated. So the first equation we're getting here, the first solution, is an exact copy of the original, but without the absolute value. The second equation is the same as the first one, except instead of positive 5, we have negative 5. So that's how you're going to get these two solutions. And that's what we're going to continue to do as we look at more and more absolute value equations. We're going to follow that same pattern. So to solve an absolute value equation, isolate the absolute value on one side of the equation first. So before you can apply that pattern we were just talking about, the absolute value does have to be by itself. So get the absolute value by itself, then you split your absolute value equation into two linear, or what I like to sometimes refer to as like ordinary or normal equations. Those are definitely not mathematical terms, but just, equations that you're more familiar with. And as we just pointed out, the first equation is an exact copy of the original, but without the absolute value. So you just copy the same equation down, but without the absolute value. That becomes your first equation. The second regular, ordinary, normal equation is going to be the same as the first one, but take the negative of the right-hand side. Excuse me. And then you solve each equation for x. So as these equations become more complicated, unfortunately, doing step 2 doesn't just give you the answer. You still have a little bit more work to do. You have to solve each of those equations you're setting up for x, and then you'll get your two solutions. All right. So let's take a look at an example. We have the absolute value of x minus 8 equals 12. All right. So what we're going to do is step 1, make sure the absolute value is by itself, which it already is. All right. Step 2, so we can go ahead and jump to step 2. We're going to split this into two regular, normal, linear equations. The first one is going to be an exact copy of the original, but without the absolute value. So I'll have x minus 8 equals 12. The second equation will be exactly the same as the first one. X minus 8 equals, the only change we need to make to this is to take the negative of the right-hand side. So instead of positive 12, we're going to have negative 12 here. Again, the reason this works is because the way we will get a solution to this equation is to either get, if we want absolute value to equal 12, there's two numbers that'll make that happen. Getting a 12 inside the absolute value, right? So if we can make this x minus 8 come out as 12, the absolute value of 12 would equal 12. So that would be one solution. But also negative 12 would work, right? So if I can somehow find a way to get x minus 8 to come out as negative 12, the absolute value of negative 12 would also be 12. So these two equations are going to help us find when does x minus 8 equal 12, when does x minus 8 equal negative 12, because both of those will work in this equation. And so that's what I'm about to find out here. So step 3, solve each of these for x. So I'll get x by itself here by adding 8 to both sides, and I'll get x is equal to 20. Here I'll add 8 to both sides, and I'll get x is equal to negative 4. All right, so when x is equal to 20, that's when x minus 8 equals 12, right? And when x minus 8 is equal to 12, the absolute value of 12 will equal 12, and so it'll make this equation true. When x is negative 4, that's when x minus 8 comes out as negative 12. And if I get x minus 8 to come out as negative 12, the absolute value of negative 12 will also equal 12, and so again, it'll make that equation true. So these are my two solutions, 20 and negative 4. All right, let's take a look at another example. Do the same thing. First, make sure the absolute value is by itself, which in this equation it already is. Starting out, most of the equations, step 1 will already be done for you, but near the end, you'll start getting some equations where you'll have to actually do something with step 1. Step 2, we'll split this into two ordinary equations. The first one is an exact copy of the original, but without the absolute value, so I'll have 4x minus 1 equals 4. The second equation will be the same as the first. It'll still be 4x minus 1, but this time it'll equal negative 4. That's the only change you want to make. And I've said that a couple times now because on the exams, when I'm grading them, I get a lot of students that want to make other changes to the left-hand side of this equation. For the most common one is to put a plus 1 here instead of a minus 1. And that is incorrect, and it will lead you to the wrong answer. And so I'll have to, you'll lose points on the test for doing that. So the left-hand side should not change at all. These should be identical to each other. The only thing that changes is the right-hand side, from positive 4 to negative 4 in this case. All right. And then, step 3, solve each of these for x. So a good way to double check that you've set this up correctly is you should be taking the same steps for both of these equations. So to solve this one for x, I'm going to add 1 to both sides first, and I'll get 4x is equal to 5, and then I'll divide by 4 on both sides. And so I'm going to get x is equal to 5/4. So that's one solution. To solve this equation, I will do the exact same steps. Add 1 to both sides, just like I did over here. And so I get 4x. In this case, the result comes out different because that's a negative 4, so we get negative 3. And then just like I did over here, divide by 4 on both sides. Right, so I took the same exact steps. So if you find you're doing something different over here than you're doing over here, you've made a mistake. You've set something up incorrectly. All right, so we get our two solutions of 5/4 and negative 3/4. All right. So here is an example of an absolute value equation where we actually do have to do something for step 1. The first step is to get the absolute value by itself. So this part right here, the absolute value part, needs to be isolated, which means the -3 needs to go, the 7 needs to go. So we're going to solve this for the absolute value portion, just like you would solve an equation. So first we'll get rid of the -3 by adding 3 to both sides. All right, so we're going to get 7 times the absolute value of q equals 8, right? Because the -3 and the +3 cancel out. Then, and there's a couple things you could do with the 7 here. But I would recommend just completely isolating the absolute value, and you should never distribute anything into an absolute value, because there are some cases where that's going to be okay, but there's some cases where that's not okay. And so instead of trying to remember when you can and when you can't, I think it's just better to just never do it at all. And to get rid of the 7 here, it's being multiplied to the absolute value, so I will divide by it to cancel it out. So I'll divide by 7 on both sides to get rid of the 7. And so we're going to end up with the absolute value of Q equals, I know this is not very nice, but thankfully there's not going to be much more we're going to have to do here. So that fraction is really not going to cause us any trouble. So we get this. So this is step 1. The absolute value of Q equals 8 over 7. Step 2 is to split, I'll go ahead and rewrite it over here so you can see this a little bit better. Split this up into 2 normal, ordinary linear equations. The first equation will be exactly the same as the original, but without the absolute value. So I'll get Q is equal to 8 over 7. The second, the left-hand side stays the same, but we take the negative of the right-hand side. So we get negative 8 over 7. And then step 3, we would solve this for Q, but it already is solved for Q. So we don't have to do anything else with it. So those will be our 2 solutions, 8/7 and negative 8/7. Okay. Let's do the same thing on this one. So the first step will be to get the absolute value by itself. So we have to isolate the absolute value, which means the 18 needs to be moved over here. Be careful. You might think to divide by 18 since it's in front of the absolute value, but the 18 is not being multiplied to the absolute value. It's being added to it. And I know there's a minus sign here. That makes the absolute value negative. But the 18 is positive, so it's really being added to the absolute value. So to cancel it out, we will subtract by 18. All right, so that minus 18 cancels out the positive 18. That negative sign is still going to linger around. So we'll have negative absolute value of 8x minus 3, left out the 8, equals negative 12. Now here's where you could make a mistake. That negative sign, if you were to distribute it into the absolute value, that would be an incorrect thing to do. And you would get something that actually is incorrect, and you won't get the right answers if you do that. So this is one of those cases where here you're not okay distributing it to the absolute value. So what we need to do with that negative sign is divide it to the other side, right? This is like a negative 1 here that's being multiplied to the absolute value. So to cancel it out, we will divide by negative 1 on both sides. Right, so the negatives cancel out. We get the absolute value of 8x minus 3 equals positive 12, right? Negative 12 divided by negative 1 will be positive 12. So that's step 1. Let me rewrite that up here so you can see this a little bit better. So step 2 is to split this into 2 equations. So you have to do this part first, get the absolute value by itself first before you can split it up like this. The first equation will be an exact copy of the original, but without the absolute value. The second equation, the left-hand side stays exactly the same, and all we do is change the right-hand side from positive 12 to negative 12. And then step 3, we will solve this for x. We'll add 3 to both sides, so we get 8x is equal to 15, and then we'll divide by 8 on both sides. And we get x is equal to 15 over 8 for our first solution. We carry out the same exact steps for the second equation. So we'll add 3 to both sides. Here, we'll get 8x is equal to negative 9. Divide by 8 on both sides, same exact steps. And we get x is equal to negative 9 over 8. All right. And so that's about as bad as these equations should get for you. So if you can do that one, if you're able to follow along with that one pretty well, you should be ready to go for any problem that I might throw at you on the homework or on the test for this material. I do have one more example though that I wanted to talk about, and so just in case, now you won't see one like this on the test because I generally don't like this as a test question. I don't think I would put this on the test, but there's going to be at least one of these on the homework. And so what's going on here, you could do quite a bit of work with this, right? You could split this up, set up the 2 equations, solve each one for x, and you'll get some answers. Unfortunately, those answers will be bad. They'll be bad. I was trying to think of a better word to use besides just the word bad, but they will not be valid. So if you were to take the answers you get, plug it back in up here, you'd find it actually doesn't work out. It doesn't make the equation true. And so this is the one thing you have to be on the lookout for, that the process doesn't catch for you. The process of solving these equations doesn't catch for you, which is that absolute values, while you can plug negative numbers into an absolute value, right? So you can have something like absolute value of x equals 2, and you can plug in negative 2 here, right? So x can equal a negative number, and that's perfectly fine, right? This is going to give you 2 equals 2. What's not okay is for the absolute value to equal a negative number, right? So plugging negative numbers into an absolute value, no problem. Absolute value handles that just fine. Having the absolute value equal a negative number is not okay. It can't happen. No matter what number you plug in here, even if you plug in negative 2, right? When you take the absolute value, it comes out positive 2. Right? So it doesn't work, right? These two sides are not equal to each other. And it never will, because absolute value never equals a negative number, right? Absolute value always comes out positive. So this equation is impossible. They're asking us to do something impossible. There's no way to get the absolute value to equal a negative number. No matter what you plug in here, when you take the absolute value, it's always going to come out positive. So this equation has no solution. So be on the lookout for that. There's going to be at least one problem on the homework where that happens. So an absolute value can never equal a negative number. Now, do not make this judgment call too quickly. All right? So if you go back to our previous example, here we have negative 12. So you might have thought the same thing, right? Well, absolute value can equal negative 12. But we didn't get the absolute value by itself yet. Once we divided this negative 1 to the other side, the absolute value was no longer being equal to a negative. So, which means it was never equal to a negative up here either. So before you can make this call, you have to get the absolute value by itself first. And if it's still equal to a negative number, there's no solution to that equation. You don't have to do any further work on it. Don't waste your time. It can't work out no matter what you do. All right. Oh, I got one more. I'm sorry. I forgot about this one. Okay. So, and this one, again, I don't think I'd put on the test. These really aren't my favorite kind of equations, but sometimes you can have one absolute value equal another absolute value. And for this kind of equation, turns out you actually don't do anything different than what we were already doing. So even though it looks like it might be more complicated, it's really, and it is a little bit more complicated, but the steps are still the same. You want to get this absolute value by itself, which should already be the case for problems like this. You're going to split it into two equations. The first equation will be exactly the same as the original, but without either absolute value. Right? So you're going to have 9x plus 10 without the absolute value equals x minus 13 without the absolute value. All right. The second equation, you're going to do the same thing that we did before. The left-hand side is going to stay the same. So we have 9x plus 10 still. But the right-hand side, we're going to take the negative of it. Now here's where it gets a little more complicated. There's two terms here. So when I want to take the negative of this whole thing, I need to use parentheses. I'm going to take the negative of the right-hand side, which is the x minus 13, and I put that in parentheses when I do that. And that's it. So you set up those two equations, following the same exact steps. First equation exactly the same as the original, but without the absolute value. Second equation, take the negative of the right-hand side. Then you solve for x from there, just like usual. So I'm going to subtract x from both sides here. And if hopefully this isn't too much too quickly here, but I'm also going to subtract the 10 to the other side, right? So I'm doing two things at once. Let's get x to the left-hand side, get the numbers to the right-hand side. You can do both of those at the same time in a case like this. So we're going to end up with 8x equals negative 23. Right? Because here the 10s are going to cancel, the x's are going to cancel, and this is what we end up with. And then we divide by 8 on both sides. And the reason I wanted to do that is because I'm running out of room here. So we get negative 23 over 8 as our first solution. This one we have an extra step we have to do, which is distribute the negative sign first. So we'll get 9x plus 10 equals negative x plus 13. And then we do the same thing. Get x to the left-hand side, get the numbers to the right-hand side. We do both steps at the same time. So we're going to get 10x is equal to 3. Then we divide by 10 on both sides. And so we get x is equal to 3 over 10. Make sure in cases where your answer comes out as a fraction that you're reducing that fraction. The examples I've done so far in this video, that hasn't been the case, right? Every fraction we've gotten has not been something we could reduce, but that could happen to you on the homework. So make sure when your answer is a fraction, you reduce it if you can. Okay, so that's the first topic in this section, absolute value equations. The second topic is a little more complicated, is absolute value inequalities. So again, to explain why we do things the way we do for these equations, I want to give you a little background information. And this has to do with distance from zero again. Right? So remember, absolute value is measuring the distance from zero. So here, for this first inequality, excuse me, we're looking for numbers whose distance from zero is less than 4. Right? So think of the real number line. Let's, I guess I'll write it off to the side here. Try to draw a line. It's kind of hard to do on here. Here's 0. The numbers that are exactly 4 away are 4 and -4. Right? So these numbers have a distance from 0 exactly equal to 4, which is not what I'm looking for. I'm looking for numbers that have a distance less than that. I want all the numbers whose distance from 0 is less than 4, meaning I want all the numbers that are closer to 0 than 4 or -4, which means all the numbers between 0 and 4, all of these numbers, right? For example, 1 has a distance from 0 less than 4. 2 has a distance from 0 less than 4. So all of these numbers that are closer to 0 than 4 is. So I'm going to shade all of them in. All of these numbers have a distance from 0 less than 4. And also the negatives of those numbers. -1 has a distance from 0 less than 4. -2 has a distance from 0 less than 4. So all of these numbers here that are closer to 0 than -4 is will fit this description over here. And we'll use parentheses on the -4 and the +4 because we don't want the numbers to have a distance equal to 4, right? So just less than 4 only. So these are the solutions to this inequality. Now, what I want to talk about is there another way we could describe this solution set using inequality notation? And we can, right? These numbers, because they're to the left of 4, these numbers are less than 4, but at the same time, they're bigger than -4, right? They're to the right of -4. So these same set of numbers, x, are bigger than -4, but smaller than +4. And because those two things have to be true at the same time to describe these set of numbers, we're going to use an and here. So it actually becomes a compound inequality like we saw in the previous section in 1.5. Right? So this absolute value inequality becomes this compound inequality. And that's how we're going to handle these absolute value inequalities, is we are going to translate them into compound inequalities and then figure out the solution from there. Unfortunately, I like writing it the way you see on the screen right now. Unfortunately, Math Excel wants us to actually write it in a different way. So what Math Excel wants us to do is join these two together into a single statement by overlaying the x's on top of one another. So it's going to look like this. So we're going to flip these around, put the -4 on the left-hand side, the x on the right-hand side. That causes this to flip around as well. And then we're going to merge these two together because it's an and. They have to be true at the same time. We're going to merge the two together. And like I said, we're going to put the x's on top of each other. So the statement looks like this now. So if you think of moving this over here and having the x's line up with one another, you're going to get -4 is less than x, which is less than 4. So it's just a different way of writing the same compound inequality. And this is how Math Excel is going to want you to type your answer, which we can only do when it's an and. So these, if you go back to the last video in section 1.5, we talked about this kind of compound inequality, and it only works this way when it's an and. You can't write ors in this way. So keep that in mind. This next inequality here, this next example, is a greater than. You might say, well, what's the difference? And we're going to try to treat this the same way as the first one, but it does have a different outcome. So I need to do both of these examples to explain the full picture. So here we're looking for numbers whose distance from 0, right, that's the absolute value part, is more than 5, right? So let's think of the, I guess I'll write it over here, the real number line. Here's 0. The numbers that are exactly 5 away are 5 and -5, right? Those numbers have a distance from 0 equal to 5. But for this inequality, I'm looking for numbers that are further away than that. I'm looking for numbers that have a distance from 0 more than 5. So for example, 6, right? 6 has a distance from 0 greater than 5. 7 has a distance from 0 greater than 5. Let me switch colors here. So it's going to be all the numbers further away from 0 than 5 is. All right, so all of these numbers here, parentheses on the 5 because there's no equals to in our inequality. And the same thing on the other side, right? We want numbers that are further away than -5 so that their distance from 0 is more than 5. So -6 has a distance from 0 more than 5, -7, etc. So these numbers to the left of -5 will have a distance from 0 greater than 5, parentheses on the -5 there as well. So to rewrite this as a compound inequality, we want x to be greater than 5, but at the same time less than, not at the same time, excuse me. So I misspoke there. We want numbers to be greater than 5, or they could be less than -5, right? They have to fit either of these issues. So it's not at the same time, because that's impossible, right? The numbers can't be bigger than 5 and also less than -5 at the same time. They just have to be one or the other to be in this solution set. So if you want to be in this set of numbers, you either need to be bigger than 5 or you need to be less than -5 to be in this set. And so this is an or, right? And so if you write this over here, I'm going to put this one first, greater than 5 or less than -5. What I want to point out to you is that the pattern here to go from the absolute value inequality to the compound inequality, if you think of it this way or this way, it follows a very similar pattern to the equations, right? So the first inequality is exactly the same as the original, but without the absolute value. So that part's exactly the same as equations, right? So I just copy this down here, but without the absolute value. The second inequality is the same as the first one, except we make two changes this time. We take the negative of the right-hand side, so that's still the same as what we did with the equations, right? So instead of +4, we have -4, but we also have to flip the inequality symbol the other way. So instead of a less than, we have a greater than here. Notice this follows the same exact pattern. The first inequality is exactly the same as the original, but without the absolute value. The second inequality, we flip the symbol around, change the sign of the right-hand side. So that's the pattern we're going to follow for these absolute value inequalities. Then we have to connect them with either an and or an or. And the way you know if it's an and or an or is based on the inequality you started with. If it's a less than, that becomes an and when you write it as a compound inequality. If it's a greater than, that becomes an or. All right. Once you set it up as a compound inequality, you get your solutions from there, just like we were doing in section 1.5. You solve each one for x, you graph them both on the same real number line, and we'll do an example here in just a second so to refresh your memory on that. All right, so let's take a look at our first example here. All right, I'm sorry, this is not an example. This is writing out the steps that I just talked about. So to solve an absolute value inequality, isolate the absolute value on one side of the inequality first, just like you would do if it was an equation. The second step, split it into two linear equations. The first inequality is exactly the same as the original, but without the absolute value, just like equations. The second inequality is the same as the first, but take the negative of the right-hand side, just like equations, and also flip the inequality symbol. Then you need to connect the two inequalities with either an and or an or. So as I mentioned, if it's a less than, you're going to make it an and. If it's a greater than, you make it an or. And then you solve the resulting compound inequality. So let's take a look at an example here. So, sorry I left a lot of text on the screen, so I'm going to actually move it over here. So we'll have absolute value of x minus 17 is less than 7. The first step is to get the absolute value by itself, which is already done for me. Right? The absolute value is already isolated on the left-hand side. The second step is we'll split this into two regular inequalities, normal inequalities. The first inequality will be exactly the same as the original, but without the absolute value. So I'm going to have x minus 17 is less than 7. I'm just copying the same thing down, but without the absolute value. The second inequality will be the same as the first one. We'll still have the x minus 17, but I'm going to make two changes here. I'm going to flip the symbol the other way. So instead of less than, it becomes a greater than. And instead of positive 7, I'm going to change the sign and make that a negative 7. So those are the two changes you have to make there. The third step is to decide whether this should be an and or an or. Now, a lot of students I notice on the test, they wait to see what the what the answer is starting to look like, and then based on the answer, they figure out whether it's an and or an or, which is probably safe 95% of the time, but there are occasionally problems where that's going to mess you up. So I would recommend figuring it out from this. So if it's a less than, that becomes an and. If this was a greater than, we'd put an or here. All right. So now we have this compound inequality that we're going to solve. So that's step 4, solve the compound inequality. First, by solving these for x, so I'm going to add 17 to the other side to solve this one for x. So we'll get x is less than 24. And I'll solve this one in the same way. I'll add 17 to both sides, and I'll get x is greater than 10. So I want numbers that are less than 24 and at the same time greater than 10. Now to type it over here into Math Excel, notice again the formatting. It's not an or, so we can rule these two out right away. It's got to be one of these two. These do not have equals to in them, so it must be option A, right? It's the only one that doesn't have equals to that's not an or. And what we're going to do to convert this into this form is flip this one around the other way. So I'm going to make this one a 10. Put the 10 on the left-hand side. Excuse me, I'm not plugging in 10 for x. I apologize if that's what it sounded like I said. But we're going to flip this around. So we're going to put 10 on the left-hand side, x on the right-hand side, and then this gets flipped around the other way. So this becomes a less than. And then we're going to overlay this x here with this x here, because it's the same x in both of those statements. So what we're going to have is, this will go first, 10 less than the x, which again is overlaying with this x now, which will be less than 24. So that's the way they want us to format this and. And so that's what we're going to type in here. 10 here, 24 here. I'm not sure if it's going to ask you this, but if you were to graph it and write it as an interval, it would look like this. All right, so here's 0 way over here. We have 10 and we have 24. And we're looking for the numbers that are less than 24, which will be to the left of 24, but at the same time bigger than 10, right? Greater than 10, which means to the right of 10. So it's going to be all these numbers between 10 and 24. Parentheses on the 10, parentheses on the 24, because there's no equals to in either one of these. So, and again, if you look at it this way, it's even easier to see. It's between 10 and 24. Right? So that's what the graph should look like. The interval is going to go from smallest, which is 10, to largest, which is 24. Parentheses on both of those. All right. I don't know that it's going to ask you for all that information, but I'd like to cover it just in case. All right, so that is how the absolute value inequalities work. Let's take a look at another one. See if I can give myself a little bit more room over here. So absolute value of 2y minus 7 is greater than 12. Again, step 1, make sure the absolute value is by itself, which it already is. Step 2, split into two inequalities. The first one's an exact copy of the original, but without the absolute value. The second one is the same, still going to be 2y minus 7, but we're going to flip the symbol around, so this will become a less than, take the negative of the right-hand side, so we get negative 12 here. All right, so that's step 2. Step 3, we have to decide if this is an and or an or. This time, because we started off with a greater than, this is going to be an or. If it was a less than, it would become an and. And then step 4 is to solve this compound inequality. So we'll start by getting y by itself. We'll add 7 to both sides. We get 2y is greater than 19. Then we divide by 2 on both sides, and we get y is greater than 19 halves. So not the greatest answer, but that's what we get. For the second inequality, we'll add 7 to both sides. We get 2y is less than negative 5. Divide by 2 on both sides, and we get y is less than negative 5 halves. Again, this is still an or, and so this is solving the compound inequality. For an or, you can never write ors in this format. So this can't be right, this one can't be right, because those are ands. So it has to be one of these bottom two. Again, we don't have equals to on these, so it can't be this one. So it has to be option D. Now, don't type the numbers in exactly the same order that you have them on your paper necessarily. You have to look at the inequality symbol. This is a less than, so I want to use the number from the less than over here, which is this one here in the first box, right? So y is less than negative 5 halves. That's this one right here. So that's what I would type into this box, negative 5 halves. Or y is greater than, well, that's this one here. Y is greater than, so that's the number I want to type into that box, 19 halves. All right, so that's what the inequality should look like when you type it in the Math Excel. For graphing, just in case you are asked to find the graph for this, it'll be multiple choice, but so you know what it should look like. We have 0 here. We have negative 5 halves over here on the left-hand side, 19 halves on the right-hand side because it's positive. Greater than 19 halves, that's going to be to the right of 19 halves. Right? Those are where the numbers are bigger than 19 halves. Parentheses, because there's no equals to there. For less than negative 5 halves, that's going to be to the left of negative 5 halves. That's where we find the numbers that are smaller, going to the left. And parentheses on that as well, because there's no equals to. And for an or, we keep everything. So this would be my answer. Keep all these numbers, keep all these numbers. Right? As an interval, it's going to go from negative infinity to negative 5 halves. And that's supposed to be a 5 right there. It's kind of hard to see. Parentheses on that. Union 19 halves, comma, infinity. Right, so we're going from smallest to largest. We have a gap here that we're skipping over. So we stop at negative 5 halves. We pick back up again at 19 halves. And so that's what the interval should look like. And we use a union symbol to show that we're joining those two together. All right, let's take a look at another example. I think I have just a couple more here. So maybe you could give this one a try. This one's pretty similar to the ones that we've already done. So if you would like to pause the video, try to work this example out for yourself, and then resume the video and see if you came up with the correct answer. All right, so what you should end up getting here is, again, step 1 is already done for us. The absolute value is already solved for. It's already isolated. Step 2, we're going to split this up into 2 ordinary inequalities. The first one will be exactly the same as the original. So hopefully if you tried this problem yourself ahead of time, you got that first one right. You just copy the same thing down but without the absolute value. The second one, the left-hand side stays the same, but we flip the symbol around so it becomes a less than. Take the negative of the right-hand side so it becomes negative 16. All right. That's step 2. Step 3, is it an and or an or? Hopefully you determined that this would be an or in this case because it's a greater than. That's why it becomes an or. And then step 4 is solve this compound inequality. So we'll start by subtracting 7 from both sides. We get negative 2x is greater than or equal to 9. And the reason I have this example on here, because otherwise this problem is just completely redundant to the one that we just did. But the difference with this problem, the thing I want to make sure to point out to you, and hopefully you caught this on your own if you did this problem ahead of time, when I go to solve this for x, I divide by negative 2 on both sides. And what happens when you divide by negative on both sides of an inequality? You have to flip the symbol around the other way. So that rule is still in effect. Right? If you divide by negative on both sides, the symbol has to get flipped around. So we get less than or equal to negative 9 halves here. Same thing's going to happen on this one. We subtract 7 from both sides. We get negative 2x is less than or equal to negative 23. We divide by negative 2 on both sides. We get x is greater than or equal to 23 over 2. Right? The negative signs, whoops, didn't do a very good job with that. The negative signs cancel each other out. But because we divided by a negative on both sides, the symbol has to get flipped around the other way. Right? This is still an or. All right, so we don't want to use this one. That's an and. This one's an and. We don't want to use those because we have an or in this case. And these have greater thans, or sorry, they have equals to on them. I don't know why I said greater thans. And so we don't want to use the first one either. So option B is the correct one. It has the less than, or sorry, I'm saying the wrong things. It has the equals to on it, and it has the or here. So this is definitely the answer that we want to choose. And this time it actually does go in the order that we got our numbers, right? X is less than or equal to which number? It's less than or equal to the negative 9 halves. That's the one we want to use in that box. So make sure you type the right numbers in the right box. X is greater than or equal to which number? It's greater than or equal to the 23 over 2. So that's what we want to type into this box here. All right. As a graph, it's going to look like this. We'll have 0 here. We'll have negative 9 halves here. We'll have 23 halves over here. Very similar to the last problem we just did. Less than negative 9 halves is going to be to the left. But this time we're going to use a bracket because we do have an equals to, so we should use a bracket on that number. Greater than 23 halves will be to the right of 23 halves. Brackets on that number also because of the equals to. And we keep everything, right? That's what OR does. You keep all the numbers that you shade in. So this would be my graph. As an interval, it's going to go from the very left-hand side, negative infinity, up to negative 9 halves, where we take a break. We resume again at 23 halves, and then go all the way from there to infinity. And so that would be my interval. All right, let's take a look at, I think, the final example in this section. All right. So here what we're going to have to do is step 1. So on all the previous problems, the absolute value is already isolated. That's not the case here. So we actually need to get the absolute value by itself, which is this part right here, before we can split it up into 2 separate inequalities. It's a common mistake on the test for equations and for inequalities that students will start off with this problem by splitting it up right away, and that's incorrect. You're going to get the wrong answer when you do that. So get the absolute value by itself first. We saw a problem like this earlier with equations. We're going to start by subtracting this positive 8 over to the other side because it's not being multiplied here. It's being added to this negative absolute value. So to cancel it out, we subtract by it. That's going to cancel out the 8's here. We'll end up with negative absolute value of 7 minus 8x is greater than or equal to negative 4. Again, we don't flip the symbol from subtracting the same number from both sides. We do flip the inequality symbol if we divide by negative, which is actually what we're going to do next, right? So to get this absolute value by itself, I want to get rid of this negative sign. I'll do that by dividing by negative 1 on both sides. And so I'll get the absolute value of 7 minus 8x is less than or equal to positive 4, right? So the negatives here cancel out. Because I divided by a negative on both sides, I have to flip the symbol around the other way, right? And so that's step 1, is getting the absolute value by itself. Step 2, split this up, just like we were doing before. So from here, it's going to be kind of redundant like we've done the last few problems. We're going to get 7 minus 8x is less than or equal to 4. Exact copy of the original, but without the absolute value. And then we're going to get 7 minus 8x is greater than or equal to negative 4, right? Flip the symbol around the other way, take the negative of the right-hand side. Because this one's a less than, we're going to have an and here for our compound inequality. All right. Now we're going to solve each of these for x, so we will subtract 7 from both sides. We get negative 8x is less than or equal to negative 3. Divide by negative 8 on both sides, and we get x is greater than or equal to. So again, we divide by negative on both sides. That symbol has to get flipped around again. And then here the double negatives are going to cancel each other out, and we get positive 3/8. We're going to do the same thing here. Subtract 7 from both sides. We get negative 8x is greater than or equal to negative 11. Divide by negative 8 on both sides, and we will get x is less than or equal to 11/8. Right? So again, the negatives cancel each other out. But because we divided by a negative on both sides, the symbol gets flipped around the other way. So a lot of little details here that are very easy to make mistakes on. So you have to be very careful going through this problem because you make one of those little mistakes and then you don't get the problem right on Math Excel, right? Because it's just all or nothing with Math Excel. This is an and. So again, I want to join these together into a single expression instead of having them as 2 separate expressions in order to format it here. It's an and, so I know I can eliminate these 2 right away. These have equals to, so it can't be the first one either, so it looks like it's going to have to be option B. And so what we want to do is, you want to flip the smaller number around for these. So this one, I want to flip this one around, right, this time. So I'm going to put the 3/8 on the left-hand side, the x on the right-hand side. That's going to flip the symbol around this way as well. And then I'm going to overlay these 2 together, right, this x here with this x here. And so I end up getting 3/8 is less than or equal to x, which is less than or equal to 11/8. And that's what I'm going to type in up here. 3/8 in this box, 11/8 in this box right here. All right, so that'd be my final answer. As a graph, you're just going to shade between those 2 numbers. Sorry, this is kind of starting to lag here a little bit. So here's 0, 3/8 right here, 11/8 right here. So make sure you put them in numerical order, right? 3/8 is smaller than 11/8. They're both positive though, so they're both to the right of 0. So I'm going to shade in between those 2 numbers, if I can. All right? Brackets on the 3/8, brackets on the 11/8 because of the equals to. So that's what the graph looks like. And as an interval, it's going to go from 3/8, comma, 11/8, right? Smallest to largest. So that's what the interval would look like. Oops. All right, so thankfully we're at the end here because this program's starting to have trouble handling all the work we've done today. So this was the last example. So this is the end of section 1.6.